Hi everybody, my name is Dave Lentica. I'm CTO and founder of Blue Mountain Labs. You can see my email address there, david@bluemountainlabs.com. You can also go to the Blue Mountain Labs website at www.bluemountainlabs.com. Today we're going to do a presentation on how to get cloud architecture and design right the first time. We're going to talk about the ins and outs and the details behind how you design clouds and how you basically go through the process. So hopefully this is helpful to you. Just some gratuitous self-promotion. Got a book on cloud computing and social convergence in your enterprise, a step-by-step guide, cloud computing blogger on InfoWorld, and also do the cloud computing podcast. You can find the slides available, this slide presentation out on slideshare.net. Just search on my name, and also there's bonus content out there on how to architect your hybrid cloud computing solution. Also, don't forget to go to www.bluemountainlabs.com for news information on cloud computing and also some of the services we provide as cloud computing consultants. So why should you care? Well, most cloud-based systems are lacking architecture. That's why you should care. A lot of people who are building clouds out there, whether it's private, hybrid, or public clouds, aren't putting the energy and time we believe is required in planning out the architecture. Basically building the system from the ground up to support the features and functions of cloud computing, allocation of resources, auto provisioning, privacy, security, identity management-based systems, governance, all those sorts of things really aren't being considered as much as they should be. And so this presentation isn't designed really to give you all the ins and outs of that, but as a jumping off point for some of the basic information you need to consider as you design and architect your cloud computing system. So the results of bad architecture are pretty obvious. Inefficient utilization of resources, so cloud computing systems can't use their storage and compute resources effectively. Resource saturation occurs. In other words, we're saturating the resources we have because we're not using them effectively. Lack of elasticity, which is a benefit of cloud computing, and scalability. So we're unable to scale up or provide the elasticity that cloud computing systems should provide, private, public, and hybrid. Lack of security and governance, talked about that earlier. Frequent outages, the things go down a lot because of instability. Bad or no tenant management. We see that a lot. People don't understand the ins and outs, the details of what tenant management actually is and architecting that into their system. And other very bad things. As you know, bad computing systems are bad computing systems, whether they're cloud or not. And if you don't put the details into the design and the resources and the planning in the design, then you're going to find that you're going to be behind the rock in the hard place in terms of stability. Common mistakes. Biggest one is not understanding how to make the architecture scale. People just don't put their time and effort into figuring out how to make things scale because they think that compute cycles and storage is commodity and therefore you just throw process and money at it. And it doesn't work like that within the world of cloud computing. You need to be much more effective and efficient with the resources you're provided. Not dealing with the tenant management issues we talked about before, not understanding that security is systemic to every step in the architecture, not understanding the proper use of services, tossing technology at the problem. That's a big thing. It's not a cloud computing project. It's an OpenStack project, or it's something like that. We're leading with technology, and that's not necessarily something that's going to be effective. Listening to the wrong people. I have a lot of people out there who are claiming to be cloud computing experts that, quite frankly, are pushing people off in the wrong directions and managing by magazine or following the hype. That's the big common mistake we see. So people try to follow the crowd, but in many instances that may not lead you to solving the business problems you have within your organization. So the multi-tenant thing. No two multi-tenant architectures are alike. I can tell you that from experience. I built a few of those in my career. You need to be effective in the context of the problem, what you're looking to do. In other words, what kind of services you're providing. Are they storage services, compute services, information production, consumption, database services, those sorts of things. And the way in which you design the multi-tenant architecture around those requirements are going to be very different from problem domain to problem domain. You need to leverage best architecture practices, and you need to look at some of the older stuff we've been doing with architecture and make sure you bring that forward. And you need to practice isolation and protection, the ability to basically isolate the resources and provide protection from other tenants in the system. It's very important. As you know, Some of the public cloud providers have been criticized, via some laboratory someplace that will test them and find out that you can, push across, virtual machines or push across between tenants, and that's ultimately going to be a bad thing. So keep that in mind. So there is kind of a silly debate over multi-tenancy. This from a blog I did, I think, back in 2011. Ultimately, people are talking about the fit, the function, and whether or not multi-tenancy should be leveraged. Excuse me. The reality is that multi-tenancy is typically going to be innate to most cloud computing systems, whether it's a software as a service, infrastructure as a service, or even a platform as a service system. And ultimately, you need to put these technologies to work if you're going to build a cloud architecture, either from other people's technology, which typically is going to be the case. We're integrating or assembling things together to form our clouds. Or you're building a thing from the ground up, which I don't necessarily recommend depending on the problem, and how to build these systems. So the ABCs of Multitenancy, and this one's from, this is actually a graphic I got from Lori McVitie, who's with and the architecture looks like this: the ability to have configuration, memory, and processors that are going to be managed independently within these systems. So as tenants come into the environment, they're basically allocated resources that are theirs, and they're protected from theirs. And when they leave the environment, those resources are deallocated. However, you are remembering where the persistent states were left. You remember how things were stored, and where the configuration was left off, and all those things are basically carried forward. But you're sharing those resources among the various things out there. We have to do that to get the benefits of the value of cloud computing ultimately, because we're looking at leveraging the same resources over and over again in different ways, and sharing those resources provides the economies of scale that cloud computing is able to bring, and therefore provides the value. How you design the multi-tenant system is going to be completely dependent on the problem domain you're looking to. But you remember, we're getting at a few things: allocation of resources, management of those resources throughout the duration of the session, and the ability to return those resources in a stable state and maintain persistence from session to session. The other thing I want to mention is virtualization, albeit a great tool for building clouds, is not always a requirement. Google doesn't use virtualization in their systems and how they do tenant management. It is going to be a decision that you're going to make as an architect as to whether virtualization is a fit or not. In many instances, it's not necessary to virtualization. I tell you that from first-hand experience. So don't always assume you're going to have to go out there and buy big honking virtualization systems from building your cloud. You may, and chances are you're going to evaluate that technology, but it's not always a requirement. So the types of cloud architecture patterns are emerging. We're migrating to cloud business systems and infrastructure, and that's a big thing right now. So we're taking our existing on-premise systems, be they big honking ERP systems, big honking CRM systems, and moving them up into software as a service. Or we're moving storage infrastructure, compute infrastructure, or even doing replatforming of systems. We're moving things from on-premise systems, out into equivalent platforms that we're finding on infrastructure as a service providers. And so understand your patterns and how you're going to leverage them. So we're building on clouds, such as platform as a service. In other words, we're building clouds within platform as a service clouds. We're building hybrid clouds, the ability to kind of mix and match private and public. And then building, building certain types of clouds. We're building them from scratch: infrastructure as a service, software as a service, platform as a service. In many instances, enterprises are involved with this today, typically not doing it from scratch, but they're certainly standing up instances of their internal systems which are able to provide patterns, cloud patterns, such as infrastructure, providing information outside of the enterprise, for example, to partners. Software as a service, we're repurposing core enterprise applications so they can be delivered over the web into mobile devices and things like that, and leveraging platform as a service ultimately to provide the ability to build and deploy cloud computing. So those are the types of architectures, and I think some of the patterns that are emerging, and the complexity goes up as you get further down the stack when you're actually building the thing yourself. And so this is one of those, don't try this at home, kids. If you're going to get into the actual building of clouds, you're going to need some specialized skills to make that happen. Migrating to clouds, a little bit less of a complex world there, because you're moving from kind of an A-to-A environment, but you're still going to need some special skills to understand how to make those migrations, how to break the architecture down into functional primitive and rebuild it out in a cloud system. So, general architectural patterns to follow. Well, this is kind of the short list. It's governance, regulatory compliance, security and identity management, business continuity, processes and services, data management, system integration, resource skills and knowledge, application readiness, network readiness, all these sorts of things that allow you to assess your vulnerabilities and mitigate your risks. So as we're moving into some of these new architectures, you need to figure out how you're going to basically move in that direction and adhere to all these 10 things, and this is kind of the short list, and then assess your risk as to how successful you are, likelihood of success in moving and migrating into the cloud computing environment, and then making sure you're mitigating the risks as much as you can. So the architecture roadmap, here's where you begin. Determine the business drivers, understand the data services and business processes and system integration points, design a cloud-friendly enterprise architecture and roadmap that leverages service-oriented architecture. I can't stress that enough. Learn the patterns of service-oriented architecture and how they apply to your domain. Determine an integration strategy for internal and external systems. Outline a migration path for legacy systems to the new architecture. And ultimately, you need SOA to leverage, a sturdy and agile foundation for the cloud. I can't stress that enough. So use the service-oriented architecture patterns. I outline them in my book specifically. And no matter what kind of architecture you're moving into, whether it's a migration architecture, we talked about that earlier, or to the very complex work of actually building a cloud within your enterprise. And so you need to leverage these sorts of architectural disciplines in order to be successful. My opinion. So it's fairly simple. You take the as-is state, we do the business case, we do data services and process inventory. We understand, we do security planning and governance planning. Then moving to the 2B, we do data services and process, and we also understand the target platforms where we're heading, private, public, or hybrid. Consider security, consider governance and how that surrounds the process. So again, security and governance is systemic to all of this. Data services and processes are ways of categorizing our existing architectures. Information that is under management, how we're storing and persisting information. Services or behaviors that sits on top of the information or data. Processes and binding these services together into solutions. And then ultimately the platforms are basically the target where we're going to take these processes, services, and data. So once we've done the 2B, we move to deploy. So when you deploy, you have to select your technology, provider technology selection and validation. You make sure you do development and testing planning, migration and testing planning, and final deployed target architecture. Having, kind of have these 4 boxes here, these very simple boxes, this is probably the most complex and problem-ridden part of the architectural life cycle. So picking the right technology is a tough thing to do, especially in a market where it's very hyped and there's disinformation out there. You need to develop and test. There's risks involved with that, and that's where the majority of effort is going to lie. Migration and testing, making sure the data arrives is in the correct state and everything is working correctly. And then deploying the final architecture, and then figuring out operational issues going forward and how you're going to bring the system into production. So general rules and guidelines, focus on the primitives. The best clouds are sets of low-level services that can be configured. Data services, transactional services, utility services. So it's a SOA thing. Leverage distributed components that are centrally controlled. Build for tenants, not users. That's a big thing. These aren't multi-user systems or multi-tenant systems, and the architectures are different in how you do both. Don't lean too much on virtualization, as we mentioned earlier, and security governance, as I can't say enough, are systemic. So where to find out more? Well, don't forget to go to www.bluemountainlabs.com. You can email me directly at david@bluemountainlabs.com. And don't forget my book, Cloud Computing and SOA Convergence, which is kind of the foundation of this presentation. Blog on InfoWorld, and we also do the Cloud Computing podcast. It's approaching episode 200. Slides, again, are available on slideshare.net, and there's some bonus content out there for you. So anyway, if you like what you've seen today, show us some love, send me an email, let me know what you think, let me know how I can improve these presentations, and don't forget about Blue Mountain Labs for your cloud computing consulting needs.